Hello and welcome to this video series where we dive into fascinating world of nanoscale device simulation and analysis. If you are a researcher, engineer or a student working in advanced electronics, this series is crafted just for you. In this project, I will guide you step by step from creating geometry using Gmsh to perform electrostatic calculation and analyzing result using QTCAD. Let's learn the objective of the project. The primary objective of this project to run the simulation process for Nanowire quantum dot and empower you with the knowledge to simulate and analyze the system. By the end of this series, you will understand how to design geometry using Gmsh for quantum and nanoscale devices, how to use QTCAD for electrostatic calculation, how to interrupt simulation results and apply them to real-world problems. Let's learn about the importance of QTCAD, why it is important for quantum device simulation. In the rapidly evolving field of semiconductor technology and quantum device, simulation tools like QTCAD have become indispensable. They allow researchers to save time and resources by predicting device behavior before fabrication, understand and optimize nanoscale phenomena that are otherwise difficult to analyze experimentally, collaborate more effectively by using standardized tools and methodology. Learning these tools bridges the gap between theoretical design and practical implementation, enabling innovation in areas such as quantum computing, nanowire, and advanced material. Our value proposition are streamline the design process with reliable all-in-one tool, simulating spin-based quantum component in laboratory conditions for advanced communication solution, security and quantum computing device. What will be the expected result from this project and what you will achieve? Hands-on experience in creating geometry for quantum device using Gmsh, running electrostatic simulation in QTCAD, analyzing the result to understand the behavior of conduction electron at equilibrium. Ultimately, this knowledge will help you contribute to cutting-edge research and development in semiconductor and quantum technology domain. If we talk about the workflow of QTCAD, the first step is device application, where we define the geometry of the device, where we define shape, dimension of the device. After that, we create mesh with Gmsh software. Then the third step in QTCAD, where we import some important libraries, where we define solver, material, and doping concentration, and analyze the result. After that, for better result, we use visualization and analysis using PyPlot, PyVista, or ParaView. And what we will cover through this playlist. For in first video introduction, after that software installation, which software are required to run this simulation like QTCAD and Gmsh. After that, in third video, we will learn about introduction to Gmsh, how to create a geometry file for nanowire quantum dot. In next video, we setting up simulation environment in QTCAD and overview of the software and performing the simulation. In fifth video, we analyze the result, extracting meaningful insight from the simulation output through PyVista, PyPlot, and ParaView. And in sixth video, we analyze application and beyond how these tools help in real-world nanoscale device research and design, like in quantum transport and quantum qubit. Thank you for joining us in this journey to explore the nanoscale. Let's get started with the first step to install the necessary software is used in this project. Stay tuned, let's begin our exciting exploration of the quantum world. I attach some file in description.